Welcome back, guys. Today we're learning about two more types of quadrilaterals. Up until now we've been learning about different types of parallelograms, but today we're going to learn some different ones called trapezoids and kites. First, a trapezoid, it's a quadrilateral with exactly one pair of parallel sides. Make sure it doesn't have two pairs of parallel sides or else it won't be a trapezoid. Some vocab: the bases are the parallel sides, and the base angles are always formed by one of the bases and the leg. So I want you to answer this: is it a parallelogram? Why or why not? There's also another type of trapezoid called an isosceles trapezoid that has congruent legs. Isosceles trapezoids are special because if a trapezoid is isosceles, then the base angles have to be congruent. So you can see here the base angle is formed by this base, GH. So angle G and angle H are congruent, and then the other base, those angles formed, F and J, are also congruent. Another special theorem about isosceles trapezoid is that if it has one pair of congruent base angles, you can conclude that it's an isosceles trapezoid. And finally, if a trapezoid is isosceles, you'll know that its diagonals are congruent, and it also works the other way around. If you know that a trapezoid has congruent diagonals, you can conclude that it's isosceles. Let's do an example together. It says the speaker shown is an isosceles trapezoid. If the measure of angle FJH equals 85, FK equals 8 inches, and JG equals 19 inches, find each measure. First, find the measure of angle FGH. For this, we know that it's an isosceles trapezoid, so I know the angle that I'm looking for, FGH, is congruent to this angle, GFJ. And I also know that these two base angles, J and H, would also be congruent, so this would also be 85. So let's call my missing ones X to make it easier. Since this is a quadrilateral, I still know that the total sum of the interior angles is 360 degrees. Another way to look at this is that I know that these are parallel lines, so I know the consecutive interior angles have to add up to 180. So there's two equations that you could write. You could do 2x plus 85 equals 360, or you can do x plus 85 equals 180. Either way, when you solve it, you should get x equals 95, meaning that the answer for the measure of angle FGH is 95. Now to find KH, I know that in an isosceles trapezoid that the diagonals have to be congruent. So I know that KH, it doesn't necessarily mean that the diagonals bisect each other. So KH, we can't just say that it's 8 inches, but I know that FH is equal to JG. Now I know that FH is the same as FK plus KH. So what I can do is write this equation. 8 plus KH equals FH, but I know FH and GJ are the same thing, so I can plug in 19 there. Now I can solve this to get KH equals 11 inches. Okay, I can also do trapezoids on the coordinate plane. Let me show you what that would look like. This says quadrilateral ABCD has the vertices given. Verify that ABCD is a trapezoid and determine if it's an isosceles trapezoid. Step 1 is to show that it's a trapezoid. So in order to do that, we have to show that it has exactly one pair of opposite sides that are parallel. To do that, we're going to find the slopes. So first, I'll find the slope of AD by doing rise over run. I have to go down 4 and over 2, so that's a negative 4 over 2, which could reduce to negative 2 over 1. Next, let's find the slope of BC, the opposite side. That one's also down 2 over 1, so the slope is also negative 2 over 1. That means that AD is parallel to BC. Now we still have to double check that the other two sides are not parallel. Otherwise, it would be a parallelogram instead of a trapezoid. So let's find the slope of AB. For that, you have to go up 1 over 5. So the slope is 1/5. And for the slope of DC, you have to go up 3 over 4. So the slope is 3 over 4. These do not have the same slope, so AB is not parallel to DC. So yes, it's a trapezoid because it has exactly one pair of opposite parallel sides. Now, step 2 is to check if it's isosceles. So in order to do that, we're going to check the lengths of the legs. So remember, the legs are the sides that are not parallel. That would be AB and DC. So what we're going to do is draw a right triangle. This has the legs of 3 and 4. Remember our special 3, 4, 5 triangle? We can do this without even doing Pythagorean theorem. I know that CD is 5. Now let's find the length of AB. Again, draw a right triangle. This time it has legs of 1 and 5. Remember, the numbers are the same as the slopes. So to find the length of AB, I can do the square root of 1 squared plus 5 squared. That gives me the square root of 26. CD is not equal to AB. That means that it's not an isosceles trapezoid. Okay. Next, you can try this practice problem on your own. Here's the correct answer. Now let's talk about the mid-segment of a trapezoid. It always connects the midpoints of the legs. An example is drawn for you. What's special about the mid-segment is that it's parallel to the bases, and also its measure is equal to the average of the bases. So let me show you how that would work in an example. So I see that LH is the mid-segment of the trapezoid, so I know 15 is the average of 18.2 and x. So let's write an equation. 15 has to be equal to the average of 18.2 and x. To find the average, you add the numbers and divide by how many numbers there are. Now, in order to solve this equation, we'll start by multiplying by 2 on both sides. We get 30 equals 18.2 plus x. Subtract 18.2 on both sides, and you should get x equals 11.8. Now let's talk about kites. So a kite is another quadrilateral. It has exactly 2 pairs of consecutive congruent sides. So I want you to tell me, why is this one not a parallelogram? It is not, but why? Okay, what's special about kites? If a quadrilateral is a kite, then the diagonals are perpendicular, so it makes 4 right triangles. That's special because it can help us to use Pythagorean theorem. Also, if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So it has to be the angle that's between the non-congruent sides. So for example, JK is not congruent to JM, so that's one of the angles. So it always has to be the angle formed by two sides that are not congruent. Let's try an example. FGHJ is a kite. Find the measure of angle GFJ. That's this angle here. Now I know that GFJ, or angle F we could call it, must be congruent to angle H, because they're the angles formed by the non-congruent sides. Again, I know that this is a quadrilateral, so I know that all the angles must add up to 360 degrees. Any quadrilateral has a sum of interior angles of 360 degrees. Let's call these X to make it easier. Now you can solve this equation. Combine your like terms and solve it for X. You should get 2X plus 200 equals 360. So 2X equals 160 and X equals 80. Therefore, the measure of angle GFJ is 80. Let's try one with missing segment lengths. It says find ZY. ZY is this segment here. I can do this by knowing that the diagonals are perpendicular. So I'll use Pythagorean theorem. So I know 8 squared plus 24 squared has to equal ZY squared. So I get 64 plus 24 squared, which is 576, equals ZY squared. So combine your like terms, you get 640. And in order to get rid of the squared, you have to square root both sides. Now I can simplify this because 64 goes into 640 10 times, and I know 64 is a perfect square. So it gives me 8 square root of 10 as the answer. And of course, you could always plug it in for an approximation. To get 25.3. Okay, I want you to try the practice problem that I gave you on the next page. Here's the correct answer for A, and here's the correct answer for B. And finally, I want you to finish filling out the graphic organizer that I gave you in class. Make sure to finish it for the kites and the trapezoids. That's the end of this unit. Hopefully you've learned a lot about quadrilaterals. I'll see you tomorrow.